So, note that this density function following also satisfying all these properties of a probability density function. So, you can remember that when we discuss the probability density function. So, this to be always greater than equal to 0. Not only that, that integration minus infinity to plus infinity f x x dx, this should be is equal to 1. So, how we can find how, so let us check that this is equal to 1 or not. So, this is equal to minus infinity to plus. So, it is 0 whenever it is minus infinity to 0, plus it is 0 to infinity, this is nothing but. So, we can first write it like this, then this is 0 minus infinity to plus 0 plus 0 to infinity e to the lambda e to the power of minus lambda x dx. Now, it is nothing but e to the power of minus lambda x, it is integration lambda 0 to infinity. So, it is we are not just putting this x value as infinity, we are taking the limit actually, it is just we are representing in this way. You have to take some, because this improper integral how we deal it, this is we have to take the integration up to some real number capital A, then you take the limit at a goes to 0. So, here also at x goes to infinity, then this goes to 0. So, that is why this is at 0 it is 1. So, that this is, so this is actually 0 minus minus of 1. So, this is equal to 1. So, that is why 1 minute no. So, this is equal to because it is minus already. So, that is why yeah. So, at 0 this is 0. So, it is minus 0 and then this is minus of 1. So, this is equal to 1. So, now this is a density function, we found that this is a density function. Now, we will find the mean and variance of this density function. So, let us find the mean. So, mu 1 dash is the mean as we have computed earlier. This is nothing but expected values of x. So, now I think you have understood that how we can find mean variances of a discrete random variable. Also, we are doing the continuous random variable, because this distribution are very important. So, we need to know their mean and variances. Later, we will utilize this information and we will not find there. We just straightforward will say that mean, because it is a exponential random variable, mean is that. It is a Poisson random variable, then mean will be this, variance will be this. Now, we are computing all those. So, now mean of this exponential random variable is nothing but by definition this is minus infinity to plus infinity x f x x dx. Now, this is equal to because it is non-zero when 0 to infinity, this is 0 to infinity x, then lambda e to the power of minus lambda x dx. So, then this is then 0 to infinity. So, then lambda is a constant. Now, we have to do the integration x 0 to infinity x e to the power of minus lambda x dx. Now, how we can do this integration? So, one way that you do it, we can do it by integration of by parts, but whenever you will take higher order moments, then it will be suppose x to the power square cube, then again you have to do more computations, more steps it is required, because you have to apply this integration of parts several times. For this reason, we will do some another simplification. We will use a concept of a gamma function, a improper integral gamma function. You may have studied in your mathematics courses, some of the mathematics courses, that integral calculus, that courses you may have learned it, gamma function. That gamma function is very much important. Using this gamma function also one distribution we will discuss, it is called a gamma distribution. So, that is why we are introducing here the gamma function. So, this gamma function for any alpha greater than 0, gamma alpha is defined by integration 0 to infinity x to the power alpha minus 1 e to the power of minus x dx. So, the you have in the integral calculus, the mathematics courses, you can say you have learned that this is a improper integral, but it is convergent and this has some value. So, this value is represented by gamma alpha. Now, for alpha is any real number, it is denoted this value gamma alpha, but whenever alpha is some integer, so there are some of the properties. So, this alpha plus gamma alpha plus can be 1 can be represented by alpha gamma alpha. So, for any real number alpha belongs to the r, alpha is not only that, alpha has to be greater than 0. So, this is alpha is belongs to 0 to infinity. Now, whenever alpha is a integer, so suppose alpha is a natural number, so alpha is equal to 1 to like this. So, then by using this property we can say, suppose alpha is nothing but some alpha is equal to let us take, because integer we just denote say alpha is equal to some L is equal to natural number. So, then what will be gamma L plus 1? Gamma L plus 1 will be L gamma L. Again you use this, this is true for L also, if you, then this will be nothing but gamma, you can write gamma L as a L minus 1 plus 1. So, that is nothing but gamma L we can represent by gamma L minus 1 plus 1. So, then we use this formula again, it is true. So, this is nothing but L minus 1 gamma L minus 1. So, this is nothing but L into L minus 1 gamma L minus 1. This will be, it can be continued till L is a integer. So, we can continue up to L 1 gamma 1. So, that is why 1 gamma 1. So, gamma 1 is nothing but, so you can see, because gamma 1 you can put, so what is it gamma 1? Gamma 1 is nothing but, it is nothing but 0 to infinity e to the power of minus x dx. So, this is nothing but the minus integration limit 0 to infinity, you take infinity at infinity goes to 0, then this is nothing but 0. So, this is minus 0 and then minus of minus plus, this is e to the power of minus 0 1. So, this is 1. So, this is it will be 1. So, so this is the because of this is minus, so I will take minus of 1, this is nothing but 1. So, gamma 1 is 1. So, then it will be nothing but L minus 1, then L minus 2, like this continue up to 1. So, in this way we can, so sorry, so this will be actually there is some representation, this is up to this it is correct. So, next we can write L minus 1, L minus 2 into gamma L minus 2, like this you can continue up to L minus 1, L minus 2 dot dot 1 gamma 1. So, that means this is gamma 1 is equal to 1. So, that is why this is equal to nothing but L factorial. So, this is nothing but L factorial. So, whenever alpha is some integer, gamma L plus 1 is equal to L factorial. So, these are some of the information of gamma function we will utilize it for your for our computation. So, some other value also it is known, we are not going to compute it, we just remember it. So, this is gamma of half. So, gamma of half, when alpha is equal to half, gamma of half is nothing but root over of pi. So, that also we will use here. So, those things you will be learning or you have already learned in your mathematics courses, integral calculus course you have learned. So, those information we will use here. So, you can remember this part and later on also we will again and again we will inform it. So, now we will find the expected values so of x. So, this is mu 1 dash expected values of x, this is nothing but 0 to infinity x lambda e to the power of minus lambda x dx. So, lambda is a real number. So, it is independent of x. So, 0 to infinity x e to the power of minus lambda x dx. So, then as we know some of the value here for this kind of integration, what we will do? We will take a transformation such that this integration will looks like this integration. So, this integration you can say it is a e to the power of minus x form and x to the power some value. So, here it is e to the power of minus lambda x. So, we will take a transformation z is equal to lambda x. So, then your dz will be lambda dx. So, then what we will do, x will be z by lambda. So, that is why, so which is equal to lambda 0 to infinity x is z by lambda and then dx is dz. So, then e to the power of minus z and then dz by lambda. So, dx is dz by lambda. So, then 1 lambda it can be cancelled and then it is nothing but 1 by lambda 0 to infinity. So, this limit will not change because at x goes to 0, then you can see that z also goes to 0. Whenever x goes to infinity, then you can see that z also goes to infinity. So, this is 0 to infinity z e to the power of minus z dz. So, remember that gamma alpha function is represented as 0 to infinity x to the power alpha minus 1 e to the power of minus x dx. So, here it looks like very same, this is same, but here z, this power it is 1. So, we have to represent it something minus 1. So, this is we can write 2 minus 1. So, then it is nothing but 1 by lambda gamma 2. So, what is the gamma 2? Because gamma L plus 1 it is whenever it is integer, gamma L plus 1 is L factorial. So, this is nothing but 1 factorial. So, this is 1 factorial by lambda, 1 factorial is nothing but 1. So, that is why it is 1 by lambda. So, that is expected values of a exponential distribution with parameter lambda, that is nothing but 1 by lambda. Now, we want to find the variance of this random variable. So, this variance of the random variable sigma square x, this is variance of x. How we will find? By definition it is nothing but x minus mu 1 dash whole square, but we will take the we will take the simplified formula mu 1 dash whole square, mu 2 dash minus mu 1 dash whole square. So, how to find this mu 2 dash? So, this mu 2 dash is nothing but expected values of x square. So, expected values of x square again by definition this is minus infinity plus infinity x square f x x dx, but this is non-zero when it is a positive. So, that is why 0 plus it is 0 to infinity x square. Now, it is nothing but lambda e to the power of minus lambda x dx. So, then we will take this same. So, we have to do this integration. So, then we will take this same transformation again. So, what we will do? Z is equal to lambda x. So, then dx will be, so x will be z by lambda. So, then dx will be dz by lambda. So, then we will just replace here and limit does not change, we have already shown it. So, x goes to 0, then z goes to 0, whenever x goes to infinity then z goes to infinity. So, this is 0 to x square. So, z by lambda whole square, then e to the power of then lambda we have already it is taken outside of this integral, it is independent of x and so constant, and then e to the power of lambda x it is nothing but minus e to the power z, and dx is nothing but dz by lambda. So, then this lambda cancelled and then it is 1 by lambda square integration 0 to infinity z square e to the power of minus z dz. So, remember that this gamma function formula is nothing but it is 0 to infinity e to the power of minus x. So, 0 to infinity x to the power alpha minus 1 e to the power of minus x dx whenever alpha is greater than 0 less than infinity. So, now if you compare with this gamma function you can see that this part is similar looking, and x to the power alpha minus it is z square. So, this z square will represent by lambda square 0 to infinity, z square will represent by 3 minus 1, then it is z square. So, e to the power of minus z dz. So, then it is nothing but 1 by lambda square, by comparing with this it is nothing but gamma 3. So, because gamma 3 is a integer, gamma L plus 1 is nothing but, so we have already shown discussed that it is nothing but L factorial for L equal to whenever this alpha is a integer equal to L. So, this is nothing but 2 factorial. So, this is 2 factorial by lambda square, this is nothing but 2 by lambda square. So, mu 2 dash is nothing but 2 by lambda square. So, hence we can find that this is nothing but 2 by lambda square, this is the mu 2 dash, and then minus mu 1 dash is nothing but we have already mu 1 dash we have already shown, mu 1 dash is 1 by lambda. So, 1 by lambda is nothing but 1 by lambda whole square, mu 1 dash whole square. So, 1 by lambda square. So, this is 2 by lambda square minus 1 by lambda square, this is nothing but 1 by lambda square. So, we just found that variance of x is 1 by lambda square. So, that is I think this is fine if there is no computational mistake. So, then this is variance of the exponential random variable is 1 by lambda square and mean of the exponential random variable is 1 by lambda. So, this is we found, and also we found probability density function and the cumulative distribution function, their graphical representation also we have discussed. So, let us discuss some example of this exponential random variable. When so suppose this example, if x is a exponential random variable, so note that when we define this random variable, exponential random variable, we say that whenever it is a PDF, so we denote it, we say x has a exponential with parameter lambda. So this is, we say that exponential, it is just a short form. Whenever we say that x is a random variable and x following a exponential lambda, that means x has a exponential distribution with parameter lambda, and then the probability density function of x is given here. So now we will do this one example. Let us discuss one example. If x is a exponential distribution with parameter lambda with probability of x less than equal to 1 is equal to probability of x greater than 1, find the variance of x. So whenever if x has a exponential lambda with probability x less than equal to 1 is equal to greater than 1. See that exponential lambda, this lambda it is not given, only it is given that probability that x is less than equal to 1 is equal to probability that x is greater than 1. So it seems it is like a, there is a definition of mean we have discussed, there is some other summary statistics you may have heard. So or it is you can just I am mentioning it, it is called a median. Median is nothing but where this you can where this is probability that x is less than equal to that point will be equal to probability that x greater than this point. For a continuous random variable, discrete it will be defined little different, but this is the concept of a median. But anyway, so here it is given that so suppose, so if x has a exponential distribution with parameter, then probability density function we know that f x is equal to nothing but lambda e to the power of lambda x, x greater than 0 less than infinity, where lambda is a greater than 0 and 0 otherwise. So now what is probability x less than equal to 1? How we can find that? Probability that x less than equal to 1 is nothing but it is minus infinity to 1 f x dx. Now this can be represented as minus infinity to 0 f x dx. Why we are doing that? Because it is 0 in this interval. So and it is different whenever it is 0 to 1 f x dx. So this is 0 in this interval. So this is nothing but 0 plus this is 0 to 1 lambda e to the power of minus lambda x dx. So that we can compute. So this is nothing but lambda e to the power of minus lambda x by minus lambda 0 to 1. So then this is nothing but, so lambda cancelled. So at 0, so basically it is negative of that. So 0 it will be positive. So this is 1 minus e to the power of minus lambda x e to the power of minus lambda x equal to 1. So x equal to 1, it will be lambda. So e to the power of minus lambda. So this is the probability 1 minus e to the power of minus lambda. Now what will be the probability of x greater than 1? So this can be okay. Now basically because both are same, so x greater than 1 is nothing but complement of x less than equal to 1. So it is nothing but 1 minus x less than equal to 1, and also so probability, so this is nothing but we can say, we can find that this is 1 minus of 1 minus e to the power of minus lambda. So it is nothing, it is just e to the power of minus lambda. So if two are equal, then what we will find? So just directly either you can find by doing integration 1 to infinity, but because it is just a complement of this thing, so just we can just directly compute it. So because it is given x less than equal to 1 equal to probability of x greater than 1, so which implies 1 minus e to the power of minus lambda, this is equal to e to the power of minus lambda, because it is given that x less than equal to 1 equal to probability of x greater than 1, which implies e to the power of minus lambda 2 into e to the power of minus lambda is equal to 1. So e to the power of minus lambda is equal to 1 by 2. So e to the power of minus lambda is equal to 1 by 2, which implies, so minus lambda is equal to, if we take log both side, log of 1 by 2. So basically it is log 1 minus log 2, so minus log of 2. So which implies lambda equal to log of 2. So, this is the value of lambda. So, now whenever you know the value of lambda, question is that find the variance of x. So, whenever you know value variance of x is nothing but what is the variance of x? Variance of x is 1 by lambda square. So, 1 by lambda square, hence variance of x is, so sigma square x, variance of x is nothing but 1 by lambda square, which is equal to 1 by log 2 whole square. So, this is the variance of the random variable x. So, we can use this, it is one example of using the exponential distribution with for this is one example, some problem related to exponential distribution. So, another question is that if x has a exponential distribution with mean 2, find probability x less than 1 given x less than 2. So, it is a conditional probability it is asked. So, how we can find that probability of x less than 1? So, it is asked that find. So, x is a, first it is given that x is a, if x is a exponential distribution and parameter it is given with mean 2. So, now we have to understand mean of a random variable we computed here, mean of a random variable is here, expected values of x is nothing but mu 1 dash 1 by lambda. So, here we computed mean is 1 by lambda. So, then mean that which is equal to expected values of x, this is given 2 and this is equal to 1 by lambda. So, which implies lambda will be 1 by 2 for this example. So, here exponential of lambda, where lambda is nothing but 1 by 2. It is given that mean is equal to 2, which is equal to 1 by lambda. So, from here we can find that lambda is equal to 1 by 2. Now, when x is exponential distribution with parameter lambda, and then it is asked that compute probability that x less than 1 by, so like probability of x less than 1 by x less than 2. So, it is like a probability of A given B. So, by definition it is nothing but probability of A intersection B by probability of B. So, from here you can get that A intersection B is nothing but x greater less than 1 intersection x less than 2 by probability of x less than 2. So, I am denoting the event like A is x less than 1 and B is x less than 2. Now, note that A is a subset of B, because whenever x is less than 1, that implies x is less than 2. So, A intersection B is nothing but A, because A is a subset of B. So, why? Because x is less than 1, if the all the value in the sample space satisfying the relation x is less than 1, then it will satisfy x less than 2. That is why A is a subset of B. So, A intersection B is A. So, that is why this intersection this will be nothing but probability of x less than 1 A by probability of x less than 2. Now, we have to find what is probability x less than 1 and what is probability of x less than 2. Now, since x is a exponential random variable with lambda is 1 by 2. So, what will be the CDF? So, either you can find directly what is x less than 1 or okay. So, you can find directly probability what is probability of x less than 1. This is nothing but integration 0 to infinity lambda is 1 by 2. So, I will just first write the formula, because it is exponential distribution, only positive part will be there. So, we will just write f x dx. So, this is 0 to infinity lambda is 1 by 2 e to the power of minus lambda x. So, this is 1 by 2 x by 2 dx. So, sorry, x less than 1. So, this is 1 up to 1. So, then this is nothing but if we take the integration. So, 1 by 2 e to the power of minus x by 2, then this will be by 1 by 2 again, and then this is 0 to 1. So, there is a negative term also. So, this is cancelled. So, now because of negative at 0 it will be 1 minus e to the power of x is equal to 1, this is 1 by 2. So, now what will be the probability of x less than 2? So, similarly we will do integration 0 to 2 f x dx, this is nothing but 0 to 2 1 by 2 e to the power of minus x by 2 dx. So, then by again the integration it will be minus same minus 1 by 2 this will be cancelled, but it will be 0 to 2. So, this is 1 minus e to the power minus 2 by 2, this is 1. So, then your probability will be probability that x less than 1 given x less than 2, this will be nothing but probability that x less than 1, what we found that x less than 2 we just found here, this is the finally we found, and then we just want to replace this respective probability, this is 1 minus e to the power minus 1 by 2 by 1 minus e to the power minus 1. So, then you can put the value e, and then you can simplify this also. So, like you can find some fraction value, approximate value of this fraction. So, this is another problem we discussed.